Since we started looking up into space, we have found millions of stars, and not one of them is like the others. Each one has its own unique characteristics and story. We've seen neutron stars, white dwarfs, red dwarfs, blue giants, and many more. And while each are truly unique, they still follow some sort of expected pattern for their type. You know, stars generally do what stars do. However, there is one particular star that doesn't do what stars do, and that is Tabby star, located 1,400 light-years away in the constellation of Cygnus. This star was relatively unremarkable until 2015, when amateur astronomers discovered that it was blinking. Now, by blinking, we mean that the star randomly dims its light by over 20% and then just as quickly returns to normal. And as of recording this video, it has blinked 9 times since 2009, with the most recent event happening in August of 2021. This erratic behavior immediately raised questions within the scientific community, because as far as we know, stars don't blink. We're used to stars either getting brighter or dimming slowly as they naturally evolve. And even when they do something weird, like pulsate or flare up, they tend to do it predictably. So seeing this star just randomly dim and then brighten again, well, it was unprecedented and really baffling. At first, scientists thought maybe there was a perfectly natural explanation. Maybe it was a previously unseen type of star, or perhaps a new phenomenon. Or maybe there was a problem with the Kepler telescope's data. After all, it had been collecting data on this star for over 5 years before the first dimming event was noticed. But after checking all of the data and performing tests to rule out any malfunctions, it became clear that the dimming wasn't just a fluke, it was real. So then scientists turned their attention to the more interesting question: what the hell is going on here? Today, there are 2 prevailing theories to explain what we're seeing. The more boring one says that there's a large planet orbiting this star that every so often passes between us and the star, which is what we see as a blink. And the other theory, well, it's a little more out there. It says that the entire star is being wrapped in a gigantic artificial structure that absorbs its light and makes it blink. If you've taken an astronomy class or watched a science show, then you've probably heard of a Dyson sphere. It's a hypothetical megastructure built by an advanced alien civilization to harness the energy of its host star. And according to one theory, that's what's happening to Tabby star. But unlike a traditional Dyson sphere, which completely envelopes its star, this one only partially does. That would mean that we see huge dips in its brightness whenever it passes between us and the star. So if we see a star suddenly dim, then brighten again, it would suggest that part of a Dyson sphere was moving in front of the star, blocking our view, and then moved away again. Now, for those who are skeptical, it's worth pointing out that an object like this would unnecessarily have to be a Dyson sphere. It could be a swarm of independent collectors in a similar arrangement called a Dyson swarm. So just to be clear, we aren't specifically talking about a Dyson sphere here. Instead, we are referring to whatever megastructure is somehow wrapping around this star. Now, this idea isn't as outlandish as it might sound. For starters, it explains all of the observations made so far. We know from Kepler's data that the star is slightly larger than our Sun and around 6,000 light-years away. If something the size of Earth passed in front of it, we would see a dip in brightness of around 7%, which matches the observations. Similarly, if something the size of Jupiter passed by, we would expect to see a dip of around 20%, which also matches the observations. And we're not just limited to things the size of Earth or Jupiter. Scientists have used this method to discover exoplanets by looking for tiny dips in their star's brightness. And what's more, this method works best when the object is around 1,000 light-years away, which is exactly how far Tabby's star is. All of this makes the idea of a megastructure much more plausible, though we should point out that it's still highly speculative. After all, there are many ways that something could be dimming the light of this star. Not just a megastructure, there could be a cloud of dust, a group of comets, or some other phenomenon. Nevertheless, the idea of a megastructure is incredibly exciting, not least because we might already have evidence of one. In 2018, researchers from Columbia University conducted a study where they looked at WASP-39, an ultra-hot gas giant around 700 light-years away. When studying the star's light, they found evidence of unusual absorption lines, suggesting that the star was being partially covered by a solid object. But it wasn't just any object. It was perfectly spherical, just like a Dyson sphere. It's worth noting that WASP 39b isn't the only place where something like this has been spotted. In 2021, scientists reported finding multiple spheres of solid objects around different stars. And in 2022, another team of scientists reported detecting 17 spherical objects around nearby stars. So it does seem like these structures are more than just a fluke. But if they are so common, why haven't we detected any artificial structures around any other stars? Well, it might come down to how big the structure is compared to its star. For example, if we were to put a Dyson sphere around our Sun, it would need to be roughly the size of Earth's orbit to fully harness its energy. And if it was that big, then it would be really obvious from Earth. However, studies have shown that a Dyson swarm could work much more efficiently if it was smaller and instead concentrated near the star. A swarm of collectors near the Sun would be around the size of Jupiter and significantly more difficult to detect. Given enough technological advancement, it might be possible to hide such a structure from view. So the further away these megastructures are from us, the more likely it is that they are artificial. It's also worth considering why aliens would want to build such a structure in the first place. It would require a tremendous amount of resources to gather enough material to build a Dyson swarm. And yet, there are multiple potential examples of them out there. It suggests that the energy payoff must be enormous. To put this into perspective, one single star like our Sun is capable of producing around 3.8 times 10 to the power of 26 watts of power. To put that number into context, humanity currently uses around 1.8 times 10 to the power of 13 watts of power. In other words, our Sun is thousands of times more powerful than all of human civilization. If we had access to even a fraction of that power, then we could solve pretty much all of our energy problems. No wonder civilizations throughout history have worshipped the stars. They really are the ultimate power source. And if there are civilizations out there that are much more advanced than us, then harvesting their power could be the ultimate goal. But ultimately, without hard evidence, we can't say for sure. Perhaps Tabby's star is just a normal star after all. Maybe the dimming is caused by something simple like a cloud of dust or a group of comets. We simply don't know. What we do know is that the next time it dims, astronomers will be ready for it. They've already started planning what they will do when it happens. They will use more powerful telescopes like Hubble and Webb to look for subtle changes in the star's light. Hopefully, it will shed more light on this bizarre phenomenon. The universe is a vast and mysterious place, and we've only begun to explore it. Who knows what wonders and mysteries await us in the great expanse of space? But one thing is for sure, with the help of modern technology, we are constantly learning more about the universe and our place in it. So keep looking up and keep exploring, because you never know what you might find. Thanks for watching. If you liked this video, be sure to subscribe so you won't miss out on any of our future videos.